when you have a quadratic function in standard form, it's like that. Y equals ax squared plus bx plus c, where a cannot equal 0. Because remember we talked about that. If a is 0, that term's gone and you just have a linear function. So a cannot be equal to 0. Other than that, a, b, and c can be any numbers that you want. And what you should have noticed when you were looking at them is just like when it's in vertex form, the a value, which is the first number there, that's if it's greater than 0, the parabola opens up. If it's less than 0, it opens down. So whether you're given a function in vertex form or in standard form, you should be able to tell by looking at the function if the graph's going to open up or down. The other thing that you may have noticed is that whatever that c value is, that's equal to the y-intercept. So if you have something like this, let's see, y equals -2, oops, let's fix that, -2x squared plus 3x minus 5. Does it open up or down? Down, because it has a negative lead coefficient. The number in front of the x squared is negative. And where would the y-intercept be? At -5. So we don't know where the vertex is like we do in vertex form, but we know that it opens down, it's fairly narrow, and it crosses the y-axis at -5. So if I were to try to kind of make a guess of what it looks like, it crosses at -5, so down here somewhere, it's fairly narrow. But the problem is I really don't know where that vertex is going to be. I don't know, is it going to be above the x-axis? Is it going to be below? I'm not sure because it's not in vertex form, so I can't tell what the vertex is. So I don't find that this form is quite as useful as vertex form. There is a way that we can find out where the vertex is. I don't think anybody would have been able to come up with it on their own, but I can ask. Anybody come up with a way to find the vertex without using your graphing calculator? No. That's okay, because I can't even remember it from one year to the next because it's not something that I would ever use. But I am going to show it to you for those of you that know. We know that the vertex is at P and Q when it's in vertex form. To find the values of P and Q, if it's in standard form, P, which means the x value of the vertex, is equal to -b over 2a. And Q is equal to c minus ap squared. Which are complicated and not easy to remember, and so I don't bother remembering. But it's up to you. If you're good at memorizing that kind of stuff, go ahead. I'm going to show you how to use this. But really, what we're going to do most often when we have a quadratic function in standard form and we want to know where the vertex is, we're just going to switch it to vertex form. So to use these equations and find the vertex, P is equal to -b. What's the value of b? -8. It's the number in front of the x. So it's -8 over 2 times a. And what's a? It's 1. Yeah, you don't see any number in front of the x squared, so it's a 1. So that works out to 8 over 2, which is 4. And then we can find q. We have to do p first because we need the p value to find the q value. So we'll take c, which is 7, minus a, which is 1, times p, which is 4, squared. And that works out to, remember the order of operations, you have to do the squaring first. So 4 squared is 16. Multiply that by -1, -16. 7 minus 16. -9. So the vertex of y equals x squared minus 8x plus 7 is at 4, -9. Those little equations are not difficult to use. I just find them difficult to remember, so that's why I say I don't use them. Over the next couple days, we'll start working on how to take an equation in standard form and change it into the more useful vertex form.